Hello everyone, today we are going to speak about this kind of waffle structures, and we will speak about how we can model it inside the Grasshopper. So let's make a new platform, and first we want to make the surface that these structures are being placed on top of. So first I'm going to start from a surface in Rhino. I use a rectangular surface. I bring it inside my Grasshopper screen by setting one surface, and I'm also hiding it inside my Rhino. Okay, so this is the surface that we made in Rhino, and now I'm going to use the surface division or divide surface. And I can give the input for the U and V divisions. Let's say they are on 12, both of them. And then we can just change the values to see different type of point distribution inside our surface. And now I want to make two curves inside my Rhino and define them as for example, mountain and the valley, which means I want this curve to affect the points to go up, and this curve to just get the points down, and it's based on their distance from these points. So I'm going to first bring these curves inside my Grasshopper screen using set one point and a curve component. And also this one. I'm going to also hide them inside my Rhino screen, and I'm going to just make a group out of it and click on block outline to make it more visible, and I can just set any color that I want. Let's say this red color, and I can add a name till mountain. And for this other one, I will do the same, and the color on blue maybe, and valley. Okay, now I want to extract the distance from this curve to this point. So that's by using curve closest point, as we discussed in the previous tutorials. I'm going to use this point and this curve. And now I want to move these curves based on their distance from I want to move these points based on their distance from this curve, and that's by using the move component and the Z vector. So these points are the points that I want to just be transferred in the Z direction, and I'm going to use a remap as we did before in the previous tutorials. You can just watch them if you need a review, and using the bounds and a target domain, which is by using a construct domain, and I will put it on start with 12 and end with 0. Let's use it in here, and as you see, as these curves are going to be close to this, as these points are getting close to this curve, they have more Z value, so they are going upper, and as they are getting distance from this curve, they are going to be less value for the Z vector. And I can also add this new curve or the valley to also affect these points. So I'm going to use another move component and affecting these new points that have been created in here. And also the process is similar, so I'm going to just copy this part and just change the inputs. So these are the points that I want to get their distance from this valley curve, and let's say the others, they can just change in this way. let's just connect this one. As you see, it has a little changed these points. We can also put it more, and as you see, it's making a valley, and here is a mountain. So let's say we have these points and we are satisfied with them, or you can also later change it, or also you can change it inside the Rhino by changing these curves. So let's say I want to just rotate this curve. As you see, it has its effect on the points, or also this one. As you see, they are affecting the whole project. And now I want to use a component which we also spoke before and we worked with. It's a surface from points, and I'm going to use these points as the input for P and this U value that we defined in the first surface division. It's important to put it on Flatten, and the U value, it has an expression of x plus 1. And now this surface is made. So let's just hide the first surface that also we had, and also these two curves. And as you see, now we have a surface that has been deformed based on these two curves that we introduced. And now I want to use this surface as the first surface of my waffle. And how I want to make my waffle is that by using two set of curves, first in this direction and the others in this U or V values, in this U and V directions, and that's by using a component named a contour. And this one is a contour set of Brep or mesh contours. This one is what we want to use. This is the surface that, this is the shape that we want to use, so I'm going to just connect this one to the S value. And the point is a point to start from, and I can just use a Deconstruct Brep and define this surface as the input for it, and using a list item I can get the vertices of this Brep or this surface that we have in here, and as you see in here, this point is the point that I have selected, and I want to define it as the point to start my contour from. And it says what direction you want to make this contours. And I can use a vector to point, which we also spoke about before, and define this vector for it. So we can also use a x vector, because we have drawn our surface just in xy, but it's better to use a vector to point to make it working if also the surface has been rotated. So I'm going to use this vector to point, and I'm going to also use a Deconstruct Brep as we used at the end of our code, and select our first, deconstruct our first surface that we had in here. And again, I'm going to use a list item and extract the vertices. So this is the first vertex and the second one. Okay, this is the vector I want to make. So I'm going to use vector to point and define these two as the inputs, and I can also put it on set boolean true, which means that it doesn't count the length of this vector, and it's just using a unit vector out of these 2 points. So this is what I want, and for the direction I want to use this vector, and so just I'm connecting this vector to the direction. And now it says what is the distance between each of these curves that you want to make, and let's start with something like 1.4, As you see, there are lots of curves made in here, so as I increase this number, they are just making a few of these curves and the distance is becoming more. And let's say it's okay for now. And I want some kind of contours in another direction. So using the same contour and the same surface, but the point, yes, we can just use this point, but the direction is different. So we should make another vector 2 points. So also let's just drag them here and use another vector, and using the other indexes of our list item, let's say we want to make this vector. So this is the point to start from, and this is the point to end with, and it's also the same, so we also have put it on true. And I'm going to use this new vector as the direction, and and as you see now, we have also made this kind of curves in another direction, or maybe U and V we can call them. This is the first stage, and let's now just hide other parts. Let's hide these points that we have made. And now we have these curves, and we want to make a waffle out of them. What's important for the waffle is that it's usually some kind of timber or other material that may be useful. And so they are some kind of slabs, or they have thickness, and also they have depths. So they're not like what we see in here, which is just a curve. So we can use extrude and define a value for it and direction to make this extrusion. And we can use the same vectors that we use for our contours. And I'm going to just use multiplication in here to make the distance from this curve to the extrusion. And I'm going to use these curves that we had in here. So the first one was this, and the value for it, let's start with 1.1. And as you see now, this is made the timbers or the slabs, and I'm going to use the same for the other parts, but I'm going to use this new curves, and also use this multiplication, but the other vector that we made in here. So if I also connect this one, you can see that both our two direction of the curves have now have a surface. They are not just curves; they're surface. And now I can also extrude them in Z direction to make them have a thickness. But it's important to consider that I don't want these two curves to just intersect together. So I'm going to use an extrusion with Z direction of, let's say, the same number for these slabs, and for the other one, maybe I can use a negative value for the Z value, for the Z vector, so that they just have the opposite direction. So using -x. Now as you see, they are just on top of each other and not intersecting. And also I can make them to have an intersection in between. So if I just move these curves, move these volumes that I have made in here. Let's use a move component and move them in the z value of this number that we had in here, but using an expression of x divided by 2. Okay, now as you see, they have some kind of intersection together. Okay. Now I can also change these values and how much they are intersected together later. But the important next part is using a Boolean difference to make these slabs have some kind of interconnection or interlocking between its elements. So I'm going to use a Boolean difference, solid difference, sorry, and you can also find it inside the intersect and the shape part. So if I connect these two inputs and just hide them, first of all you can see that it doesn't work correctly, and the reason is that for just the number of items in each part. And to just solve this problem, we need to I had to flatten both of them to make this working, and we spoke about the flatten in the previous tutorials. You can just watch that. And now as you see, these are the these slabs that we had in here. And if we also want this kind of interlocked to work for the other part, because it needs to also cut this part to just fix them together and being interlocked. And this solid difference asks for a volume to be cut from and a volume that is the cutter. So we should do the same by copying this component. Let's also disable this one because it's a little heavy. And now I should just change the inputs for this component. So this is the first component, this is the first input, and this is the second one. And now you can see that it also works. Yeah, you can also have these parts that are removed from your slabs. So now if I use a custom preview, I can just make them clear and different from each other. So using a custom preview and a color swatch, as you see, these are in one direction, and in the other one I can use another color. Okay, now you can see it, the difference between these two parts. If I just hide this part, you can see that now this timbers in here have this kind of cuts inside so that they can be interlocked. And that's it. But you can also change where they start from, or where they if you want them to be extended in this part. And for making this kind of changes, you can just change this start point that you use for the contour. For example, in here, if I just use a move component and change it in the based on the vector that we also used for this direction, which was this one. If I use this and add a number like 0.4, and if I connect it to the point that I want to be used as the start for the contour, you can see that it can be different from what it is in here. So as you see now, it made a difference. Or we can add to this number, like we put it on 0.8. And also in the other direction we can also use the same. Let's just copy this part, or I can just copy this part, and instead of this direction for this values, I need the other direction, which is this one. And if I also connect this one to the P, you can see that it's becoming a little, so that it's not completely in the end. So if I also add to this number, let's put it on 1.4 and check how it looks like now. Yeah, now it's better. This looks better. Okay, that's it. I hope you enjoyed it, and we will continue in the next tutorials.